Okay, welcome back. Welcome back. Now we're going to have a conversation about building for the future. We're going to talk about innovations in technology, some building technology, other types of technology. And it's my honor, my pleasure, to have Professor Christoph Reinhart from MIT, from the School of Architecture and Planning, who will be leading the discussion and will introduce this terrific lineup of panelists that we have. So Christoph, thank you.
Are we on? Can you hear me?
Should be good. Yeah, you're
Great. Welcome to our afternoon panel titled Building for the Future, New Innovations in Process and in Technology. Thanks a lot to the Center for Real Estate for having us here. I hope you had already a wonderful 2 days of learning. We are covering this afternoon, we are talking about innovations, technology in the sector, and when we first met over the phone together, we decided we want to focus on how do you design, construct, and maintain the built environments. And all of us are going to present individual examples from our work of how we're making that happen. The idea is for everybody to stay as close to 3 minutes as possible, and then I'll start off with 1 or 2 questions, but we are really keen on having an engaged audience, so please then chime in, ask your questions. There will be microphones handed out, and hopefully we all learn from each other. Quickly, I'll start. Oh, sorry, I should introduce the panel. Next to me is Santiago from Schneider Electric. Afterwards, Rosana. Wong from Lee Limited, joining us from Hong Kong. Then we have Erich Klawuhn from View, joining us from the West Coast. And from Toronto, we have Zenon Radewych from WZMH Architects. So we have a whole bunch of players that represent different parts of the construction sectors, and we're interested in learning what you're all doing in that area. To give you just a quick overview of what MIT is doing when it comes to smart cities, innovative cities, our Department of Facilities and our Office for Sustainability have for a long time treated the campus as a living lab. So as you see in this picture here, we have this virtual net on top of our campus where our various departments are collecting a lot of data from energy to how people movement through spaces, and then they're making this available to the larger MIT community. And that, of course, triggers innovation in the sense that we are looking at real-time optimizations on how buildings work, the Internet of Things, linking constantly new products to our existing data systems that we have, data visualization, all these type of things. And the 2 projects that I'm going to talk about are part of this very large MIT infrastructure. One is related to an auto-calibrated urban building energy model for our campus. So the way this works, this uses machine learning techniques to automatically use monthly energy data for all buildings on campus and then predict what the energy saving potential for each building is and how much carbon we could save. And we tested how well this actually works with our Department of Facilities. So that was a fun engagement where we had facilities create a list of the top 10 best buildings for retrofitting on campus. And we have our algorithm create another top 10 out of 160 buildings. And then we had a very fruitful discussion. And the idea was not to say we have an algorithm that replaces people, but we have intelligence assistants where the algorithms can say for a building, you're using a lot of ventilation. If your building program allows this, you could, for example, in one of our buildings save 2,500 tons of carbon emissions per year. And we see a lot of value in this being created, that facilities know what happens in their building and they have a hunch, but they don't know how much they will actually save. And then another large topic across our campus is the movement of people between buildings, through buildings, and in cities. So how can we predict and understand how this goes? And in a large measurement campaign in one of our courtyards, we measured for 11 months the flow, Wi-Fi data of everybody moving through that part of the campus. We collected 30 million data probes in total, and we could then clean up that data. We knew we had in that time 670,000 visitors to this courtyard and 15,000 regulars. And by trying to understand what these regulars are doing, you see here this strong correlation curve which uses biometric metrics to simulate every hour of the year what the outside conditions are, and we could link that very well to when people are within the space. So you can use this for all kinds of services. You can either say which are the parts in the city where a lot of people will be gravitating to, which can be good for locating a business. But you can, of course, also use this for urban planning purposes to decide where you actually want people to walk and bike in the future. So we see this as a new type of planning tool that helps cities to revive certain neighborhoods if they plan to do that. This is some background from academia. Of course, we have real practice right here, and we're starting off with Santiago Torres from Schneider.
Thank you, Chris. So I thought I'd first give you an idea of who we are and what we do. As you can see from here, we are a growing technology company. Our focus is on the digitization of energy management and automation. We're about a $29 billion company, and we operate all over the world. To give you an idea, about 40% of our revenue comes from new economies. And we are focused on end users, on end markets, which are in the buildings area, which is 40% of our revenue, but also data centers, industry, and energy. We invest about 5% of our annual revenue in innovation. A lot of it is digital innovation. As a matter of fact, about half of our revenue today derives from connected products, from edge control, from software, from services, artificial intelligence used to enhance services, that type of thing. As a matter of fact, in buildings, we already have our products and services and software installed over in more than 1 million buildings around the world, which gives us a lot of data to play with and to add value to our customers. And the other thing I wanted to point out is that we are also a big real estate user. So we have about 50 million square feet of real estate of our own, 137,000 employees, and we use this to really drink our own Kool-Aid, right? Do it at home first and experiment with our technology and learn from it before we bring it to market. So with that, I'll turn it over to Erich.
Thank you. My name's Erich. I'm with View. View's a smart building company based in California. And for the past 7 years, we've been producing and installing dynamic glass. And what you're seeing on the left-hand side there is dynamic glass installed for window buildings. And what it does is it's based on electrochromic technology, and it allows you to eliminate blinds and shades for glare control. And the benefit that you get from that is daylight. Daylight's been proven to improve humans' well-being, our attitude, and our productivity. So that's the play and the benefit for the occupants inside. There's also a pretty tremendous thermal comfort advantage to this glass. It's much more energy efficient in terms of blocking the solar load from coming through the glazing. And what that results in for developers and tenants is they can occupy closer to the glass itself. So it's common for occupants to have everyday workstations right next to the glass, where traditionally that kind of isn't possible. Usually people are set maybe 5-8 feet back from the facade. So this glass is all connected through an IoT platform that's cloud connected. Each glass can be individually communicated to. So from a future-proof standpoint, you create zones of grouping of glass for different use cases. So whether it's a lobby, a conference room space, an individual office, these can be changed through software and just configuration. And when you have a cloud-connected infrastructure like this, you can then do that remotely without having to change any wiring at all. So then just moving on a little bit about the future, we're moving into humanizing buildings is the way that we think about this. And there's three parts to it. One is senses. And we've already created some senses on the building with the dynamic glass platform. There's a cloud detection sensor, which is tracking real-time cloud in a microclimate above the building, and then also integrating weather feeds through the things that power our weather feeds on our cell phone. Making it intelligent for making the tinting choices of the glass. So leveraging that further, we're putting sensors throughout the building, kind of what's shown schematically here, and we think about those as the human-like senses for the building. Then we combine that with the brains, and the brains is compute and storage power, which is driving that platform and connecting those sensors. And then finally, a nervous system, which is the connection to all of those. So we're taking what we've been fairly successful at in getting dynamic glass in this IoT platform in buildings, and we're leveraging that into more applications and more sensors, if you will, to provide value into the buildings. I didn't mention over that 7 years, we've installed about 450 projects of airports, commercial office buildings, healthcare, higher education. In fact, we're installed here at the Boston Logan Airport. So then a couple of the applications finally that this enables, a building security. So when you have this type of infrastructure, any glass break can be immediately detected and you know where that glass break is. So we announced that product late last year, and that's enabled on our platform. And then the future platform, things like this, which is a sensor assembly that has the capability of air quality, occupant movement and density in spaces so that you can learn from that. And it's part of the core and shell of the building. And then a little further out finally is on glass displays. So the ability to display information, full 4K video feeds onto glass. This is something that will be connected through a platform like this and part of the future about where we're headed. Thank you.
The green one?
The big green one.
Okay, so I'm Zenon again. WZMH Architects, we're an architectural firm based in Toronto, Canada. Been around since 1961. About 2 years ago, we decided to basically invest heavily and study and really dive deep into the prefab, modular, off-site construction world. But our focus diving deep into this prefab world has really been about tackling or not tackling, but basically looking at 3 different things that we feel are important to seeing the prefab world become very successful. And the first thing is to look at solutions where we basically integrate as many of the different components. We call them disciplines because we work with electrical, mechanical, structural engineers, etc. But trying to combine the different components of a building into one component. And we'll talk a bit about that in a second, what we've done. The second thing that we're looking at is when we prefab this building, this structure, basically looking at creating an intelligent highway, a common vendor-neutral highway for all of the devices that get plugged in and that operate from or within the building. And then the third thing is actually looking at what we're calling the DC building, the DC world, pushing the DC side as much as possible and pushing the AC back. And there are many reasons for that. I think one simple reason is the fact that today the buildings that we live, work, and play in have a lot of already DC infrastructure in terms of the lights, the speakers, the security systems, et cetera. So that's really been our focus when looking at the prefab world. It's how we integrate various disciplines into one component, how we push for this intelligent fabric, and how we create this DC world. And that's really changed our office in terms of, if you came to our office 2+ years ago, you'd walk around, you'd see a studio of designers and architects and technicians designing and drawing buildings. Now you'll see a component of our office dedicated to industrial designers, people that specialize in software, electronics, playing with little gadgets that are actually designing some of these things. And we've actually now even partnered with non-traditional consultants, companies that specialize in electronics design, for example, that are helping us build some of this stuff. So one of the first things that we actually built, we're now at our 3rd prototype, is what we call the intelligent structural panel. And it's basically a 2-inch thick sandwich panel. It was actually developed in the UK, the structural component itself, but it's a very thin structural panel that's the equivalent of 8 to 10 inches of concrete or steel deck and concrete. And what we did is we inserted an intelligent layer. Basically, inside that sandwich is our layer of intelligence that allows the plug and play of all of these different building devices, like the lights, the speakers, the cameras, even certain HVAC components. We could probably plug and play the view glass. We could plug that all into our structural panel. So as the building gets assembled and is built, and you're dropping these structural floor panels down, you're already installing probably about 70 to 80% of the building infrastructure already in place as you build the building. And at the end of the day, it's basically a true plug-and-play system. The jacks are working right now with our RJ45 jack that basically allows you to plug and play. There's no junction boxes, etc. And what's really key to this whole thing about what we call the 6-in-1, where you integrate different disciplines, is we've realized over the last 2 years is we're actually reducing the amount of materials we use in the actual design and construction of a building. So by combining electrical, IT, even some plumbing and HVAC into one product like a structural floor panel, you actually eliminate certain materials. So we've done some calculations. We believe we're now at about 10% less material use when you integrate versus a traditional build. And that's kind of interesting fact because right now a lot of the green programs out there don't recognize buildings that use a lot less material than other buildings. So that's one big advantage over and above the fact that it's modular, it gets built very quickly, it's plug and play, it's safe, and it's DC based, which is very much pushing the IoT world, right? So which kind of led us to now partnering with companies like Microsoft, who are helping us kind of understand how all of these connected devices communicate with the cloud, how we keep the devices secure, the information secure, et cetera. But that's really been our focus. It started off with prefab, but how we really kind of integrate different components into one, and then how we basically push for an intelligent highway that's vendor neutral. Plug any dumb device into our system, and it automatically becomes smart by means of it communicating with other devices. And then the last thing is really pushing the DC world.
Great, thank you. First of all, I'm Rosana. I'm from Hong Kong. And thank you, MIT's kind invitation. Allow me to be here for this 1.5 days, which is truly wonderful. And actually, my background is basically running the family business based in Hong Kong. Primarily, we are a developer, contractor, service provider, and manufacturer. And also 2 years ago, we actually moved into Science Park. I set up my own VC funds called Ophelia Ventures. Basically, within the VC fund, I have basically 9 startup companies. We want to look into 4 pillars: infrastructure, environment, care, and transformation. This is something that we try to work towards smart city. Now, in here behind me, I want to share with you what we've done for the past sort of decade. About a decade ago, we disrupted ourselves. We look at the entire thing about how to build in terms of our software, hardware, our processes, and material. And subsequently, the result was this hotel in Soho area in Hong Kong. And the end result was not only we achieved 4 platinum awards, LEED, you call it here in this country. We achieved platinum. In Hong Kong, we call it Hong Kong Beam Plus, we got platinum. In Singapore, we call it Green Mark, we got platinum. In China, we got 3 stars. We achieved 3 stars, which is equivalent to platinum. All together, together with sort of like 15 awards. More to the point, we save energy. We save 2 million kilowatt of energy per year without fail. That's equivalent to about 3.3 million Hong Kong dollars per year, and the ROI is 25% year on year. That's 10. We also use Powerbox, something that we designed to monitor it in real time, just to see in here, I'm in Boston. I can see exactly what's going on within my hotel in terms of energy level and water level, so that we can actually see the baseline simulations that we designed the building and the actual results. We have hundreds of sensors within in the hotel. We see it really as a walking lab for us. And the other middle picture there is my current project as a developer as well. And we bought this land in a very sort of a poor neighborhood. We need to revamp it. We need to rejuvenate it. So with that, not only we use what we call the whole full life cycle management, and again, we use BIM, building information modeling, to actually design, and it wrote an add-on onto a software that we use. We use Revit, ArchiCAD, but in this particular case, we wrote an add-on called Eco Design and Star onto ArchiCAD. So within this virtual design construction concept, it only took us, ladies and gentlemen, 6 meetings, only 37 working days. We managed to frozen the design from our model and generated the information back to 2D and submitted to my government. Therefore, we have a permit to build. Yet, at the same time, we key in all the data into our Eco Designer Star. Within 6 meetings, 37 working days precisely, we managed to achieve not only gold, but platinum, the Hong Kong Beam Plus Award. We've done that. And again, our BIM Society awarded us, the Provisional Platinum Award. We are just doing piloting right now. At the same time, we have also converted this API into 3-star, which is the certification for China. So what we're trying to do is just play and muck around. So our building, our development is residential, come commercial, and we want to promote what we call intergenerational living, whereby we want grannies to enjoy the kids, and we want to have more open space, actually, for barrier-free for people with wheelchair. And then we can actually see what we've done equivalent to, like, if you put the whole thing in Shanghai, Beijing, and Guangzhou, within our add-on, we can see precisely whether we can achieve platinum or gold, whether it's suitable or not, especially when it comes to like greenery, which we ought to have some sort of balance. We all have greens, but then again, when it's too much green, we have to have high maintenance costs. So this is basically what we do. Now, the last picture there is something that our Hong Kong government is heavily promoting right now. It's called MIC. modular integrated construction, on the basis that we want to promote construction 2.0 as well as industrial 4.0. Basically, we try to put more AI into what we do, robotics, and this hits the bill. Basically, we've been doing prefab for over 3 decades now. But the breakthrough was we managed to basically break down to a flat, which is, you have to think a small size, okay? We're very tiny, weeny in Hong Kong. The size about the flat is basically 700 square feet. We managed to divide it into 5 boxes, and that 5 boxes with a structural wall included, with all the furniture fittings inside, all the bathroom fittings, everything's in it within the 5 boxes. And then we manufacture that in our manufacturing hub, and then transfer it to Hong Kong to actually our construction site. Now, my client is actually, we designed this for our government. Basically, they're thinking, if you do all this prefab, how do we keep track on the quality? So what we've done was, with 2 of my subsidiaries, one is a construction software company, together with my BIM company, as well as my startup company, we created something called Bini. Now, this platform, I believe, is truly amazing to the point that we can keep track on the design 2D details. Together, we embed the sensors into our prefab unit, RFID, and then we put things into the model. So you can actually see 3-dimensional in a BIM viewer exactly what's going on at any one time. And then the last bit is we link it into blockchain. Those really important items that we need to keep track, especially when it comes to our quality. So you can see at any time we hash it. So basically, our government still can see the result 100 years' time from now. So this is our latest development, and I'd love to share with you more to the point we want to collaborate. This is what we're here for. So thank you, Chris.
Thank you. Lots of innovation here. I think from all the images that we saw, my son would have loved the TV in the window best. I think the notion for a 12-year-old of having TV everywhere is compelling. There's a big trend right now that we are talking throughout the world at MIT also about the combination of technology and design. We are coming up with our whole college here, the College of Computing, where MIT is investing a lot in basically creating a new genre of people that understand computation and technology, but also have design sensibilities. And I heard something similar from all of you since you develop products. So I wonder how you're doing this within the company, how integrated a part that is. Who are the people that we need to educate to serve companies such as yours?
I'll go. So basically, in our basic experience in the last 2 years, when we started off with this, we call it the intelligent structural panel, and creating an intelligent layer and then basically connecting devices to that layer, we had to kind of create a software platform to kind of, proof of concept, prove that those connected devices could actually talk to each other, and how they talk to each other, all that kind of stuff. And that's kind of when we hit a wall because, we kind of had the expertise to kind of build a panel, understand what kind of goes inside, but then when we started plugging in devices, how do we actually have those devices talk to each other? And we were plugging in a combination of dumb devices. We were buying, for example, lights from Home Depot and plugging them in, and we were plugging in some smart devices. Our infrastructure for the panel was PoE-based, Power over Ethernet. So there were a lot of devices we bought, off-the-shelf PoE devices that had already smarts and came with software, but we also installed a lot of dumb devices that had 0 smarts. So it was kind of how to make those 2 different components or sets of devices talk to each other. And we hit a wall, and that's where we had to basically go and find people that specialized in software and programming and what I call like breaking the code and stuff like that. To kind of help us. And since then, we've now realized the importance of having them on board to kind of really understand, how devices talk to each other, why we want them to talk to each other. It's not just that we want everything to talk to each other, there's got to be a reason for it. And so, like I mentioned earlier, our practice has grown to basically now include people in our office that come from the non-architectural background. Also, from that, we started developing what we call black boxes, they're black boxes basically that allow us to plug in dumb devices and have them PoE powered, but it gives them smarts. And again, we understood how to build that from a physical perspective. We kind of understood some of the components that went inside, but we really needed some, electronics people, engineers to kind of help us and specify the right parts, and then again, write the software, the code. So I think it's extremely important, for firms, architectural firms, and the traditional engineering firms like electrical, mechanical, IT, to kind of bring on this expertise to kind of really understand how these different systems talk to each other to really see the benefits of a building that's fully integrated and everything truly talks in the way that it should talk.
If I could add to that, look, I think it's very easy to be seduced by the new buildings. You were speaking about smart cities. We have to recognize the fact that if you think about the buildings that are going to be in existence in 2050, 30 years from now, 75% of those buildings already exist today. So to really get to that smart city vision, we really need to do something about the legacy buildings. How do we make them new? How do we advance their technology and live with legacy technology to enable them to be spaces where people want to be, to enable them to be spaces that can compete with new buildings, right? And still remain part of the fabric of the city. So, I think to answer your question, the focus, I think, needs to be on doing not just the new, but in bringing the old to be new as well.
And who do you hire to do that?
Well, we're looking at you to do that, right? To develop people like that. But look, there's a lot of technologies that exist today because, and they're really being driven by the economics of one building wanting to compete with another one. Buildings having to keep up with the new buildings, and there's many ways to do that. But in most cases, you have to be able to integrate legacy technology into the future, because otherwise it becomes prohibitively, the cost becomes prohibitive and it doesn't become economical.
If I could just mention a couple things. From a design perspective and integrating into the design process, we found it a necessity to invest in this area. When you come with a new technology that the industry for the most part wasn't familiar with, dynamic glass, we need to educate and be able to show how the architectural design may be able to embrace and be enhanced by the dynamic glass. So I was sharing with Christoph that we are using many of the tools that have come from him and MIT in terms of daylighting, energy modeling, thermal analysis as part of the design process with the architectural and MEP community. And then furthermore, we've taken our control system to a three-dimensional level, meaning these facades and designs of the buildings obviously are three-dimensional, and we learned that adjacent objects such as other reflecting buildings, bodies of water, shading of trees and buildings, they play an effect on how you both design, and the architectural community has known that, but also how you control the glass. So from a design perspective, we're integrating that in as a provided free service to help the awareness and the education during the design process about how to use dynamic glass and how to use it effectively. And we've had to hire up experts, had a couple or one of your students as part of our team as well. So it's been a great investment for View to do that.
Can I just add one thing to what Santiago mentioned? He's perfectly right in terms of, moving forward, this isn't just about kind of the new buildings and the greenfields. There's a huge opportunity to look at basically the existing building stock in terms of, for investors, for developers, for the owners to actually convert those buildings into smart buildings. Literally, I don't want to say overnight, but there's a lot of new technologies, and we're working on with some of our partners to basically take some of these buildings and within, say, a 6-month period, convert them into smart buildings. And when you really think about a lot of the buildings, if you just stick with, say office buildings, for example, a lot of office buildings that are even 50 plus years old have had some sort of retrofit done to them in the last 15, 20 years, everything from LED lighting to security systems to new elevator systems. So there's already, call it, a portion of those buildings that's new, that's a lot easier to integrate into some of this new technology. So there's a great opportunity, and we just finished a workshop in our office looking at some of these 70s, 80s vintage office buildings, and there's about 10 plus things you do to them to kind of convert them into a smart building, literally within a 6-month period. So you start thinking about some of the new buildings that are being built today. When you see a new building being built today, it was designed and drawn about 4 or 5 years ago. So, the competitor across the street who has the old building could convert their old building into a smart building within 6 to 9 months, and technically maybe have a building that's actually more state-of-the-art versus that building that was designed 5 years ago, but the shovel's going in the ground now, or just being finished now, right? So a lot of opportunities in the retrofit marketplace to go back and change a few things, rewire a few things, and all of a sudden you'll have a smart, intelligent building. You know, I mean, the view glass, I mean, it goes into an existing window mullion system, so you're not replacing the skin, you're just replacing the panel itself. Now, what you connect to is a different story, but there's opportunities like that that actually allow you to kind of go and turn these old buildings into smart buildings, you know, increase the value of the asset within a very short period of time and compete against the competition across the street.
I see we have two new friends over there. Rosana, what is your...
Basically for us is we want to build a smart city because we want to provide better choices for our people. More importantly, dynamically is what we're trying to work on. Like for instance, one of my startup companies doing urban planning. So we design urban planning in the sense that we can not just look into like the building we've done. We save energy, one building, so what? What can we do with one building? We need to really immerse that into the city level. And the scale we're talking about is about 1 millimeter square. We really want to build a smart city for the future. So with that, for instance, one of my startup company, Urban System, basically is the very first company in Hong Kong that we got what we call the moving permit for autonomous vehicle, and we have 3. And this autonomous vehicle, what we're trying to do is not just us, but we collaborate with people globally, including my partners here in the States as well. So what we're trying to do is speed up the process to do things in an exponential manner. So within the 9 sub companies that we have, from urban planning to IoT, we're doing like smart lamppost to integrate things together with the autonomous vehicle, and then we look into the smart building. How can we do and sustain that? That is the question that we very much want to look into. Especially in our Hong Kong, we have a typhoon. So in a sense, our wind code for our building is really stringent, really, really high. So we put a lot more safety factor and rebar to build that. And again, other places got earthquake. So how do we look in this in terms of climate change? It's something that we very much like to work with people globally as well, including MIT, of course. So we can do research in the future that we can actually, when we actually get built in that manner, we can actually have a chance to sustain that. I think that's the goal from our perspective.
Great, fantastic. Actually, Steve asked me particularly to involve you all, and I think that's the best way to do. If there are any burning questions from anybody here, we have several mics stood up. Feel free to engage. I have a whole bunch of questions, but I think that way I know that you are alive.
Question over there.
Like one there.
Hi. You know, I think real estate gets a little bit of a bad rap. We're talking about how we don't innovate, but all I see is innovation up on the stage. Where do you see the pivot point happening? As some of these technologies, you mentioned 450 projects with view glass, where do we start saying that the real estate industry is really leading the way in innovation as opposed to just following behind?
I'll start just since you were pointing at me. So it was a journey of finding an initial technology, finding the right fit, and in the real estate environment, it's also at the right scale. When a brand new technology is coming on, you can't expect to be, you know, the urban tower on day one. And we've been going through that journey, and airports, for instance, just unlocked for us. It's a tremendous fit of value proposition to how airports are designed with dynamic glass. But you know, airports are big public spaces. So it took a little bit for us to get projects out there, for the trades to be comfortable, for occupants to be very satisfied and have testimonials. And we had to invest in some of that early on. And now we're seeing the market, you know, it took, what, five plus years, I would say, to kind of get that. And now I can tell you that we're winning, you know, downtown New York City towers now. So I think in some ways you got to earn the right of a new technology to be able to fit into a building implementation like that, especially when it's core and shell, because it's, you know, so integral to it, right?
Look, I think, to complement what you said, I think it's important to look at what other industries have gone through. If you look at the industrial automation business, which we also play in, there's about 50% automation and connectivity to the cloud today. If you look at real estate in buildings, it's only about 20%. And you have to wonder why. Industry is, I mean, manufacturing sites or continuous processes of sites are always looking to draw productivity from their processes, right? And the connectivity into the cloud has enabled things like Industry 4.0, where you can do predictive maintenance, benchmarking across plants, benchmarking across competitors, across geographies, to draw even more productivity out of a plant. Extrapolating to real estate, where we've only taken what I would call baby steps. the economics also have to be there. And what the connectivity of buildings into the cloud is enabling today is to do exactly that for the real estate stock assets. So it's becoming easier to be able to compare, the cost per square foot of operating a building in a similar latitude in one country versus the other, or how to get to best in class. And you start asking the questions about how do I get from where I am to the benchmark. And through the analytics, through the connectivity into the cloud, a lot of these things are going to, which have real economic outcomes for the tenants, for the developers, for the service providers, and so on and so forth, will enable that. Of course, bringing along the challenge of cybersecurity as well, right? Lessons learned from the industry side.
I wouldn't mind asking a question back and forth, because I agree with technology and this cloud connectivity. It needs to happen for many of these technologies to happen. And we've had our challenges, and Santiago, I'd love to hear your point too, of getting the building and the tenant, the building owner and the tenant, or the tenant, to give you that cloud connectivity. We've struggled with this. We're cloud connected to nearly all of our installs, from a serviceability, configuring the system, monitoring, upgrading even. So pushing upgrades like what you get on your phones. But it's been a challenge to get the building owners or the tenants to give us that, to the point where we install cellular modems by ourselves. We've seen definitely a trend, it's got to be off the tenant's network. So I think the future of adoption of these technologies is there needs to be a building network that needs to be separate from the tenant network, that will provide these kind of core infrastructures and technology enablements. I would love to hear your point from your experience on that.
Look, it's a very natural resistance to connectivity. The driver to it, on the other hand, is if you don't connect, then your building is guaranteed will start losing value through time.
That's right, yep.
You will not know how far from its original commissioning, at what condition it's operating. So there's many ways of doing this, but ultimately the client needs to understand, or the end user needs to see the value in doing that. Look, as I mentioned today, we predict that 75% of the building stock in 2050 exists today already. So for us, it is absolutely central to our strategy to be able to have an answer to something like that, Erich. And the way we do it is, for legacy systems, for legacy buildings, is just educate the customer in the sense that it's not just the technology. Technology is a factor. It's the technology, it's the people, it's the process. So it starts with an assessment of what you have, an education of the people. It's not a one-time event, but a continuous process. Yeah. And the reason for which we've learned this is, we are the convergence of operational technology and information technology, coming from the industrial automation side. And the same type of standards for cybersecurity are being applied in building automation systems. So starting from making sure that the products of the software that are brought into the building are built through a process that is certified, making sure that the processes for assessing, monitoring, and the continuous monitoring of the processes is also certified, is something that should give the peace of mind to the client so that they can get the benefit of that without necessarily putting their operation at risk. And look, I mean, everybody has seen the headlines about, Target being attacked and their database of customer credit cards being stolen when a hacker went in through the thermostat of the building, right? Things like that scare, and with good reasons, scare potential clients, but there are solutions to that.
Precisely. I just want to briefly mention the stuff that we do in one of my startups is basically doing cybersecurity and merging that into our building maintenance. Because with that, we can actually add a little bit extra cost, but then again, the value of what we're trying to do is tremendous. Because again, couldn't agree more that cybersecurity is so important, especially if you apply it in a smart city manner. But one of our golden rule is, my golden rule is, we shouldn't do anything more than 5 years payback. Because I feel like we ought to live in a reality whereby commercially it has to be viable as well. It's something that's so tremendous, in terms of one of the water technologies that we're into, but the payback is 20 odd years. Even though I love to do that, but it just seems to be impossible to commercialize that. I think that's also very important, and in particular, to look into the project whereby it got to be localized in a sense that is for the local standard to be able to adopt that as well.
Zenon,
I just wanted to add one thing in terms of the whole issue of technology and innovation and construction and why it's maybe kind of slow moving and the issues. I mean, two issues that we've seen in the last 2 years and specifically in the last 6 months on one of our projects where we're trying to kind of get our panel installed is the building codes, the authorities, right? So, our industry kind of in general has kind of been slow, but the authorities, the building codes are very, very slow to kind of adopt, and they just can't keep up with, the pace of change that's happening now in our industry in terms of modular, prefab, and new technologies. So that's a big hurdle. The authorities, the governments have to kind of, catch up and get on board and kind of understand what we're doing and put a process in place to kind of have the approvals happen much quicker and much sooner. The second thing is that we've witnessed is the fact that although we talk about a lot of collaboration, we still very much design and build in silos. So there's the architects, there's the mechanical, electrical engineers, structural engineers. Although we're collaborating and meeting, we are still kind of designing in silos. And the same thing happens on the construction sites. You have electricians doing the high voltage, and then you have different guys doing and women doing the low voltage and different systems. There's not a lot of true integration. And our experience in the last 2 years is sitting at the table with the full complement of all the disciplines, including the building side, and just talking about what we want to accomplish. There's a lot of great brainstorming that happens in that room, and a lot of people challenging each other, and for the first time, people hearing questions they never heard before, or answering things that couldn't be answered before. So there really has to be a better way to kind of collaborate together versus working in silos. And I think when you start seeing some of that collaboration, you'll start seeing a lot more innovation coming out of our industry. And again, the authorities have to really kind of catch on and speed up to where we want to be.
The gentleman has been waiting very calmly. Thank you. I'm sure there's a storm in the inside that waits to be released.
No, fantastic discussion. No problem at all. And thanks to all of the panelists. And I wanted to touch on, actually, towards the end there, you were getting to my question, which is the authorities, or let's say in a more broad sense. Our last questioner talked about real estate being late to the game in innovation. Well, construction's even farther behind that, right? And so we did a study, and I want to ask you this, Mr. Perez. When we looked at the global construction companies around the world, 67% of those companies invested less than 1% of their revenue in R&D at all. You mentioned spending 5%, which is a remarkable sum, because the highest that we saw was in places like Asia, where these things are a lot more advanced. And so, Ms. Wong, I'd like you to comment on this as well. How, as a construction company, were you sort of able to take what is generally a low margin service and really invest that kind of money, capital, into these new innovations? Because what we find generally is contractors are normally just dragged along by the real estate and property owners and or the governments to implement new innovations like BIM or blockchain or things of that nature. So I'd love to hear the panel's view on that.
So thank you for the question. First, I'll clarify, we're really not a construction company, because if we were, I think those challenges would be very real to us, right? We are a technology company. And what we do is we make electrical distribution, electrical secure power backup, digital energy for managing buildings, the products, the edge control, the software, the services, which is at a different level of profitability than a construction company. Why do we invest so much? I'll answer your question. Look, to us, as a technology company, it is the only way to be able to stay relevant to our customers. Because it's not just that we're pushing new technology, it's the customers are demanding more performance, more outcomes, better outcomes. And so to be able to do that, you reach a level with, there's only so much you can do by just enhancing a product. But the analytics that come with it, let's just give you a specific example. Being able to switch the entire business model from doing preventive maintenance on an asset in a building to doing predictive maintenance. Think about how much cost you can take out from the operation, from the OpEx of the building by somebody not having to show up, right, every single time to just do a routine check on something, check, and back out, between travel, time spent there, as opposed to just being connected and being able to monitor the sensors whether they're thermal or vibration or correlation of a whole bunch of different data to understand when it's about to fail. And so only then you dispatch your service technician with the right tools, with the right capabilities to be able to do something about it, or better else, even better, you fix it remotely. So things like that, that's just an example that add huge value to the entire value chain of a building, are what enables us to be able to invest in the technology and motivates us to continue to do that.
Can I just add one more thing? I think a lot of the larger builders are investing in technology in terms of helping them have safer construction sites and being more efficient in terms of building these buildings. But where they're not investing, and I don't think it's their fault, is actually investing in new materials and how we put these materials together. And I think that has to be done by the designers, by the manufacturers, and companies like View of looking how you integrate different components into the glass. So they come with a glass product where they integrated IoT sensors and shading, et cetera. So I think it's the industry that has to the suppliers of the different materials have to be innovative in terms of coming up with new ways of combining materials, new materials, to make the whole process a lot more fast, more efficient, more cost effective, smarter, et cetera. I think some of the big construction companies are going in that route where they're getting into prefab and modular, and I think that's going to be the stepping stone to them when they start assembling these products, looking at different ways of assembling. Because right now, currently, all of this prefab and modular work that we're doing is simply being installed and assembled with the exact same materials that we use on site, but simply being installed in the factories. To me, that's not good enough. We need to take it to the next step or next 10 steps and actually look at, again, as we mentioned earlier, combining materials, looking at ways of saving materials waste by combining different components. To me, that's true prefab and modular. We don't have to necessarily build prefab Lego boxes, but we could look at prefabbing walls that aren't built the same way they're built today with gypsum board and studs. It could be a wall that's only an inch thick that has all the electrical components inside of it, right? So it's that type of thinking process that has to happen, I think, on the manufacturing side, that'll go back to the construction side, and then you'll really see the innovation move.
So Steve was giving me the hand, and I'm going to oblige because he's taller than me. I think, what did we learn? I think there's a lot of innovation that's coming and making its way into real estate. That's the good news. I think the bad news is that we have to do that in 5 years payback times, at least in Hong Kong, which is hard to swallow given how long buildings stand in the world. So maybe that's something to discuss more. Thanks a lot, Steve, for bringing a fantastic panel of speakers together, and hope of you they will all stick around. Some have to catch an earlier flight, but grab them now, ask them all that you want to, and help me thank them for coming to MIT.
Thank you. Thank you.